This is Rakey. Welcome to DevOps Nexus channel's latest explainer. Today, our main goal is demystifying Docker by bridging the gap between high-level theory and actual practical application. Fun fact for you, Docker actually started as a quirky internal side project at a company called .cloud before, completely revolutionizing the entire cloud industry. So today, we're taking those abstract concepts you constantly hear thrown around in the DevOps and cloud-native communities, and we're going to turn them into real, actionable skills that will directly elevate your engineering workflow. Okay, let's dive into this. If you've spent literally any time at all writing code, collaborating with a team, or trying to push an application to production, you have absolutely heard, or let's be honest, probably shouted, this universally dreaded phrase, "but it works on my machine," right? It's the ultimate developer pain point. You spend hours perfectly configuring your local laptop, the code runs flawlessly, but the second you pass it off to a staging server or hand it to a teammate, boom, everything completely breaks down. To cure this deployment headache once and for all, here is our roadmap for today. First, the My Machine problem. Second, containers versus virtual machines. Third, key Docker terminology. Fourth, your first hands-on container. And finally, best practices and security. This roadmap is going to take us straight from a conceptual solution right into hands-on execution. Section 1, the My Machine problem, the origin of Docker. Let's formally identify the problem that makes containerization so necessary. Before we learn how to use a new tool, we really need to identify the exact origin of the chaos. The root issue? Well, it almost always comes down to environmental dependencies. You're dealing with different underlying operating systems, slightly different versions of Node or Python, maybe missing system libraries or conflicting background services. Enter Docker. Docker is a platform for containerization that explicitly solves this frustrating problem. Think of it as the hero of our story today. It allows you to logically package your application and absolutely every single one of its dependencies, the runtime, the system tools, the exact library versions, the whole shebang, into one single standardized unit. It guarantees a consistent, identical environment no matter where the code is ultimately running. Moving on to Section 2, containers versus virtual machines. The core comparison. To truly grasp what Docker is doing, we've got to contrast it with the older way of deploying applications. Now, what's really interesting about this slide is how it cleanly contrasts the clunky, heavy nature of virtual machines against Docker's lightweight, efficient containers. In the past, achieving isolation meant spinning up a heavy virtual machine. But a VM requires a hypervisor and its own full-blown guest operating system just to run. That eats up a massive amount of memory, CPU, and storage. Docker containers, on the other hand, bypass all that heavy lifting. They share the host system's kernel and don't require a bulky guest OS. This makes them incredibly lightweight, meaning they can start up in milliseconds rather than minutes, and you can pack way more containers onto the exact same hardware. Section 3, key Docker terminology, the building blocks. Before we hit the command line, we're going to quickly build a strong mental model with 4 absolutely essential terms. First up is the Dockerfile. Every single container starts right here. Think of the Dockerfile as the exact blueprint, or a really strict, step-by-step set of instructions for building your application environment. It's just a simple text file that tells Docker what base operating system to use, which application files to copy inside, and exactly what installation commands to run. Once you've authored that blueprint, Docker uses it to build an image. An image is the executable package. You can basically think of it as a static, immutable template. It holds your application code, the runtime, the libraries, the environment variables, the config files, everything. And because an image is completely static, meaning it never changes once built, you can be 100% certain that it will behave the exact same way every single time it's used. Let's move to and see how this builds. What actually happens when you bring that blueprint to life? Well, when you take that static image template and command Docker to execute it, it becomes a live container. The container is simply the running, breathing, interactive instance of your image. You can easily have dozens of identical containers running simultaneously, all safely spawned from that one single static image. And finally, we have Docker Hub. Once you've successfully created these amazing, perfectly packaged image templates, you need a secure place to put them. Docker Hub acts as a massive cloud registry. It's very much like GitHub, but specifically for Docker images. It's where you can safely store, version control, and share your application templates with the rest of your engineering team or even the public open source community. All right, Section 4, hands-on first container, executing the workflow.
This is where we finally pivot from foundational theory to hitting the terminal for some hands-on execution.
Let's say you're deploying a simple Node.js app. Step 1 is executing docker build. This is the command that reads your text-based Dockerfile blueprint and physically compiles your Node environment into an image. Once that compilation is done, we move to step 2, which is docker run. This is the core magic command that takes your newly minted image and immediately launches it as a live, isolated container that serves your app. Finally, step 3 is docker ps. You just type this into the terminal to list out and inspect the status of all your actively running containers, ensuring your application is actually healthy, online, and listening for traffic.
And this brilliantly illustrates how the modern developer pipeline flows seamlessly from start to finish. You move logically from a declarative blueprint using Docker build straight into a tangible running application using Docker run. It's a beautifully simple, highly predictable workflow that finally takes all the guesswork out of your deployments.
Section 5, Best Practices and Security. Scaling your knowledge. To operate like a true DevOps Pro or SRE, we must quickly touch on how to manage these containers responsibly. Getting a single container running cleanly on your local machine is a fantastic milestone for sure. But to operate in a real production environment, we need to implement professional best practices from day one. So the crucial point is using Docker Compose when an application requires multiple containers. Modern production apps are rarely just one isolated container, right? You usually have a front-end web server, a back-end API, and a database. Docker Compose is an orchestration tool that lets you define and run all those multi-container applications together with a single command. Next, always optimize by keeping your images as small as possible. Don't bloat them up with unnecessary OS tools or cache files. Keeping it lean drastically speeds up deployment times and saves network bandwidth. And finally, prioritize security. Catch those vulnerabilities before they ever hit production by regularly scanning your images, and always run your containers with the absolute minimum required privileges. We've journeyed all the way from solving that incredibly frustrating "it works on my machine" problem, contrasted lightweight containers against those bulky traditional VMs, mastered the fundamental terminology, and stepped right through the vital command line execution workflow. But as we know, technology never stands still, and mastering a single container is just the beginning. Now that you hold the core building blocks to reliably containerize your applications, I leave you with this. How will you scale your newly containerized apps to reliably serve thousands or even millions of users across a global cloud infrastructure? Think about the amazing possibilities orchestration platforms like Kubernetes will bring to your pipeline. If you found this explainer valuable and you're ready to unlock the next steps in your tech journey, make sure to subscribe to the DevOps Nexus channel for more high-level SRE and DevOps content. Keep building, keep scaling, and I'll see you in the next explainer.